scalar product of two vectors. In this module, you will learn to find the scalar product of two vectors. The scalar product of non-zero vectors A and B is defined as the product of magnitudes of vector A, vector B, and cosine of the smaller angle between them. Dot is the operation symbol for the scalar product. The scalar product of vectors A and B can also be interpreted geometrically. If a perpendicular is drawn from the end point of vector A onto vector B, then OM represents the orthogonal projection of vector A on vector B. Now, consider the right triangle OAM. The ratio of the base to the hypotenuse, that is, magnitude of vector A, is equal to cos theta. This equality helps us to deduce that the base of this right triangle is magnitude of the vector A into cos theta. Thus, the scalar product of vectors A and B is the product of magnitude of vector B and the scalar component of vector A along vector B. Similarly, dot product of vector B and vector A can also be obtained by multiplying magnitude of vector A and the scalar component of vector B along vector A. The dot product of vector A and B can be obtained by either multiplying the projection of vector A on vector B by magnitude of vector B, or by multiplying the projection of vector B on vector A by magnitude of vector A. This fact helps us to conclude that the dot product of two vectors is commutative. The dot product of two vectors is maximum when theta is equal to 0, as cos theta will have its maximum value 1 when theta is equal to 0. This fact helps us to conclude that dot product of unit vector I cap with itself is equal to 1. Similarly, j cap dot j cap is equal to 1 and k cap dot k cap is also equal to 1. The dot product of two vectors is minimum for theta equal to pi, as cos theta has minimum value, that is, -1 for theta equal to pi. This fact helps us to conclude that dot product of two vectors is negative of the product of their magnitudes for theta equal to pi. Next, if A and B are two vectors and lambda is any scalar, then the dot product of lambda times vector A and vector B is equal to lambda into dot product of vectors A and B, which is further equal to dot product of vector A and lambda times vector B. In this module, you have learnt that